This is for G, finding the equation of a line. And really, we're going to be using, for most of the occasions, y equals mx plus c as the general rule for the equation of a straight line. Remembering that m stands for the rise over run, or we could use y2 minus y1 over x2 minus x1. We can substitute into this to find, or once we know m and a point, or we can use this rule here, which does those two steps in one go. But as to which equations we use and the order that we do it depends upon what we know. So here are a few examples. If I know the gradient is 4 and the y-intercept is -2, I can sum straight into this and say that y equals 4x minus 2, and there is my equation. If, however, you know m and you know a point, you can jump straight to 2x plus c, and then you can sub in this information to find c. So y equals 6 when x equals 1, 6 equals 2 times 1 plus c, 6 equals 2 plus c, c equals 6 minus 2 or 4, therefore y equals 2x plus 4. Notice that I did two things. I substituted the m first, then I substituted this point to find c. You could do that all in one step by using the y minus y1 equals m x minus x1 rule, which says y minus the y value is 6 equals m is 2, x minus, and x is 1. Y minus 6 equals 2x minus 2, y equals 2x minus 2 plus 6, y equals 2x plus 4, the same answer as we got there. I like this rule because the x and the y are there for you, and they make finding the equation at the end a bit easier. But there is no reason why you can't substitute the 2 in for m, and then substitute the 6 and the 1 in for x, and work out c, and then put it all together at the end. You get the same answer. If you had 2 points, I would probably need to work out m first by using this rule for m. So I'll do that first. M equals y2, 0, minus y1, 6, over x2, 8, minus x1, 4. -6 on 4 equals -3 on 2. So my gradient is -3 on 2, so I know that y equals -3 on 2x plus c. So I might choose a point. I could choose either of the points. I'm going to use this point, which means I have 0 equals -3 on 2 times 8 plus c. 0 equals 2 goes into 2 once, goes into 8 4 times, minus 12 plus c. c equals 12. Therefore, my equation becomes y equals -3 on 2x plus 12. Remembering, I could do the same thing using the y minus y1. y1 is 0 equals -3 on 2x minus 8. Y minus 0 is that -3 on 2x plus 2 goes into 8 4 times 12. Same answer, less number of steps. And the last example we have here is where we have a graph that's drawn. Very, very similar to example 3, where we have two coordinates, 5 and 0, and 10 and 5. So to do a gradient triangle, rise over run, my rise goes from 0 to 5 or 5. My run goes from 5 to 10, which is 5. Therefore, my gradient is going to be rise over run, which is 5 on 5, which equals 1. I would have got the same rule for m had I've used y2 minus y1 over x2 minus x1, 5 on 5 equals 1. Whether you use rise over run or this rule, you'll get the same answer and either is acceptable. So we've got y equals x plus c. I could sub in a point. I might choose this point. 0 equals 5 plus c. c equals negative 5. Therefore, y equals x minus 5. Often in these questions, there's a range of things that you can do, and you can choose whichever you feel most comfortable to do.